Okay, here we go, working with ratio segments. We're going to learn how to solve similar triangle problems using the ratio segments from particular pictures and situations. So please copy your I can statement. And then here for vocabulary are those particular pictures of those situations. I can't remember if these are in your notes printed already. If they are not, please get the name down and the pictures for sure, and then read through the descriptions with me, and we'll add a few notes on the pictures. The triangle proportionality theorem basically says that if you have a parallel line that runs parallel to one of the sides of the triangle and intersects the other two sides, then that line divides it into those two sides proportionally. I like to refer to it as part to part. Your teacher may have some better ways to name it. And on this side, meaning on side BC, it has split parts also. So you might hear me say part to part or part to a whole side. You'll see how it works as we get into the examples. The second one is the triangle angle bisector theorem, which basically says you take any angle of an angle and bisect it. That means you cut it in half with congruent angles there. Then that angle bisector also splits the opposite side into two segments that are proportional to the sides closest to them. Now that's a mouthful, but I like to say it's something like this. This side and this split part is proportional to this side and its split part. Again, your teacher may have a much better, simpler explanation of it. Those are some of the phrases I'll use to describe the situations. The problems are easiest to understand by just doing a few examples and getting the hang of it. Example 1 says find the length of BE, so they've labeled that with an X. And since it's got the parallel lines going on here, then we're doing the triangle proportionality theorem, and that's part to part. And we'll set up ratios based on that. So let's go part to part down the left side. We can go 5.5 to 2 and match that in the same order on the right side, part to part. That'd be the top part and the bottom part of the splits. You can set up that proportion and solve it. Another possibility would be if you were looking at it like top part to top part, bottom part to bottom part. Solving either one of these proportions will give you the exact same answer. We'll quickly run through the math, and then we will not always show the math. You should be using cross products like we've done before. 3 times 5.5 is 16.5. 2 times x is 2x. Divide by 2. You have an answer of x equals 8.25. You just found x, so you just found BE, which is what was asked for. And you are done. So this proportion here would have given you the exact same value of x. So you don't necessarily always have to use the same one someone else uses. You can still get it correct. In example 2, we'll do the same type work, but the question, notice, is actually backwards. In example 1, it said because the lines were parallel, we had to find a missing part. Now we're going to try to prove that the lines are parallel, so we're trying to say, yes, it would fit that triangle proportionality theorem. So let's set it up, part to part, part to part. And if what we set up is true, a true statement, so put a question mark, will it be true that 9 to 3 is the same as 10.5 to 3.5? If we do the math to prove, to show that those two ratios are equal to each other, then that's proving that those lines are definitely parallel. There's two ways you can do this. You can simply use a calculator and reduce each fraction, divide each fraction, and see what you get. If you get the same number, then you're going to say, yes, the lines were definitely parallel, or you can compare cross products. I'll do it both ways, and then you can kind of pick which one you like or which one your teacher prefers to go with. 9 divided by 3 is 3. 10.5 divided by 3.5 in your calculator is also 3. Does 3 equal 3? You say yes, so you say The line segments are definitely parallel because it fit the triangle proportionality theorem. The other way to prove that would be set up the cross products and show me that those are definitely equal numbers. 9 times 3.5 is 31.5. 3 times 10.5 is also 31.5. You're asking yourself, is that equal to each other? Once again, you'd say yes. So that makes the line segments parallel. Whoa, good one, Miss Brimhall. All right, example 3, same question. Are the lines definitely parallel? Let's check the triangle proportionality, part to part, and part to part. And if we have equivalent ratios, then we'll say yes, they're parallel. If we do not, we'll say no. So let's write 11 to 7, asking ourselves if that's equivalent to 5.25 over 3.5. If you do it the division way, 11 divided by 7 is a 1.57, and it continues. 5.25 divided by 3.5 is 1.5. It has to be exactly the same, so those are not equal, so you're going to say no, not parallel segments. The other way to check it is do your cross multiplying. Either way with a calculator is just as quick as the other. If you multiply 7 times 5.25 and 11 times 3.5, these are the numbers I got. Those are not equal to each other, so once again, not parallel. In example 4, we'll be working with the triangle angle bisector theorem, which basically says you split an angle and bisect it in half, then these two splits parts of this opposite side match up with their matching sides, or closest sides. So x plus 2 is 7 is proportional to x plus 1 with 5.6. Other possibilities would also give you the correct answer if you happen to see it and want to write it as 7 over x plus 2 compared to 5.6 over x plus 1. There's even a third way where you could do 7 to 5.6, x plus 2 to x plus 1. They would all give you the correct answer. I'm going to go with this one right here and write out my cross products. So 5.6 times x plus 2, that's one cross product, equals 7 times x plus 1. There will be some distributing here. Just be careful with your algebra. This gives us a 5.6x plus 11.2, 7x plus 7. I'm going to choose to move the 5.6x over to the right side by subtracting it. That leaves me with a 1.4x plus 7 on the right-hand side and an 11.2 on the left. Now if I move my x's to the right, I'll move my 7 to the left. That gives me the equation of 4.2 equals 1.4x. Do your division. You should have x equals 3. Make sure you pay attention to the question asked, because in the geometry pictures, you're not always done just when you find x. We need to find the length of BD and DC. The length of BD, don't write it with the line segment over it because you're going to represent the number. BD is right here. It's represented by x plus 2. So that'll be easy. 3 plus 2. BD is 5 units long. The length of DC is represented by x plus 1. Also easy math. That's 4 units. You have found exactly what was asked for. That's right. Make sure you've got it under control because we will be having a quiz and or a test before you know it. That's all.